We've been planning to colonize the wrong planet this entire time. And the thing is, everyone knows it. Scientists know it, NASA knows it. But we keep throwing billions of dollars at Mars anyway because it looks like somewhere we could live. Meanwhile, Jupiter's moons are sitting out there with actual oceans, magnetic shields, and energy sources that Mars can't even dream of. Mars has been the poster child for human colonization for decades now. Every space agency, every billionaire with a rocket company, every science fiction movie, they all point to Mars like it's the obvious next step. And I get it. Mars looks kind of like Earth. It has polar ice caps, it has dust storms, it has valleys that look like rivers used to flow through them. You can look at pictures of Mars and think, yeah, I could imagine walking around there. But here's what nobody wants to admit. Mars is a dead planet. It's been dead for billions of years. And all the things we're planning to do there, build underground cities, melt ice for water, terraform the atmosphere, those aren't solutions. They're expensive band-aids on a planet that can't support life. Today we're going to talk about why Jupiter's moons, specifically Europa, Ganymede, and Callisto, are actually better options for long-term human survival than Mars ever will be. And by the end of this, you're going to wonder why we've been wasting our time with the red planet at all. Here's the core problem with Mars that nobody likes talking about. Mars doesn't have a magnetic field. That sounds like a technical detail, right? Like something only scientists care about. But it's actually the single biggest reason Mars is a terrible place for humans. Earth has a magnetic field. That invisible shield surrounding our planet is the only reason we're alive. It deflects solar radiation. It deflects cosmic rays. It protects our atmosphere from being stripped away by the solar wind. Without it, life on Earth wouldn't exist. Mars used to have a magnetic field. Billions of years ago, Mars had a molten core that generated the same kind of protection Earth has. But then the core cooled down, the magnetic field died, and after that, the solar wind just slowly ripped away most of Mars's atmosphere. What's left now is about 1% of Earth's atmospheric pressure. 1%. So when people talk about living on Mars, what they're really talking about is living underground, permanently, because the surface is being blasted with radiation levels that would give you cancer in months. You can't just walk around in a spacesuit. You can't build surface cities with domes. The radiation goes right through. And there's no fixing this. You can't turn a planet's magnetic field back on. You can't generate one artificially on a planetary scale. It's not a solvable problem with any technology we have or can even imagine right now. This is the challenge. Mars looks like home, but it's a radiation-soaked rock with almost no atmosphere and no way to protect one even if we built it. So the question becomes, if we're going to live underground anyway, if we're going to need artificial protection from radiation anyway, if we're going to need to generate our own heat and energy and water anyway, why does it matter that Mars looks familiar? It doesn't. Let's start with Europa, Jupiter's fourth largest moon, and the most likely place in our solar system to have life right now, not in the future, right now. Europa is covered in ice, thick ice, but underneath that ice is an ocean of liquid water that's deeper than all of Earth's oceans combined. We're talking about an ocean that might be 60 miles deep in some places. Earth's deepest ocean trench, the Mariana Trench, is only about 7 miles deep. Europa's ocean makes that look like a puddle. How do we know there's water under there? Gravity measurements. When spacecraft fly by Europa, they can measure how the moon's gravity pulls on them, and the data shows that there's a layer of liquid underneath the ice. We've also seen plumes of water vapor shooting out from cracks in the ice, geysers that spray ocean water directly into space. But here's the interesting part. That ocean isn't frozen solid because Europa is being constantly heated by something called tidal flexing. Jupiter's gravity is so strong that it squeezes and stretches Europa as the moon orbits. That squeezing generates heat, a lot of heat, enough to keep an entire ocean liquid, even though Europa is 5 times farther from the sun than Earth is. And where there's liquid water and heat, there might be life. Not complicated life. We're talking about microbes. Maybe something like the creatures that live around hydrothermal vents at the bottom of Earth's oceans, places where sunlight never reaches, but life thrives anyway because of chemical energy coming from the planet itself. Now, could humans live on Europa? Not on the surface. The surface is one of the most radiation-blasted places in the solar system because it sits right in the middle of Jupiter's intense magnetic field. But under the ice, that's a different story. The ice shields you from radiation. Water is one of the best radiation shields that exists. So if you built a base underneath the ice, either floating in the ocean or anchored to the seafloor, you'd be protected. You'd have unlimited water. And if there's a geothermal heat source down there, and scientists think there probably is, you'd have energy too. The challenges are real. You'd need to drill through miles of ice. You'd need submarines that can handle crushing pressure. You'd need to figure out how to grow food in an underwater environment. But these are engineering problems. Hard ones, sure, but they're solvable with technology we understand. Compare that to Mars, where the core problem, no magnetic field, no atmosphere, isn't solvable at all. Ganymede is the largest moon in the entire solar system, bigger than Mercury, bigger than Pluto, and it's the only moon anywhere that has its own magnetic field. That's huge, because a magnetic field means protection. Not as strong as Earth's, but strong enough to create a mini magnetosphere around Ganymede that deflects some of Jupiter's radiation. It's not perfect protection, but it's way better than Mars, which has none at all. Ganymede also has water. Like Europa, it has an ocean buried under its icy crust. But unlike Europa, Ganymede's ocean is sandwiched between layers of ice. There's ice on top, liquid water in the middle, and then possibly more ice underneath, and then a rocky core at the center. It's a weird structure, but it means water is accessible. The surface of Ganymede is cold, really cold, about -160 degrees Celsius. But again, if you're building underground anyway, temperature matters less. You need heating systems regardless of where you are in the outer solar system. What makes Ganymede special is that it's stable. Europa is constantly being stretched and squeezed by Jupiter. That creates heat, but it also means the surface is chaotic, cracking, shifting, with geysers and constant geological activity. Ganymede is calmer. Its surface is ancient, billions of years old in some places. That stability makes it easier to build long-term infrastructure. And there's another advantage. Ganymede is farther from Jupiter than Europa. That means less radiation. Not zero, but less. Enough that surface activity might actually be possible for short periods with the right shielding. Think about it this way. On Mars, you can't go outside without a thick radiation shield, and even then you're taking a risk. On Ganymede, you've got a magnetic field doing some of the work for you. It's still dangerous, but it's manageable. Now let's talk about Callisto, Jupiter's second largest moon, and the most boring one. which is exactly why it might be the best choice. Callisto is far enough from Jupiter that the radiation levels are almost reasonable. You'd still need protection, but nowhere near as much as Europa or even Ganymede. Callisto also has water ice all over its surface, and probably an ocean underneath like the other moons. But what makes Callisto special is that it's geologically dead. Nothing is happening on Callisto. No tidal heating, no volcanic activity, no shifting ice. Just an old, quiet, cratered surface that hasn't changed in billions of years. For scientists, that's boring. For engineers trying to build a permanent human settlement, that's perfect. You want a stable foundation. You want to know that the ground underneath your base isn't going to crack open. You want predictability. Callisto gives you that. It's the least exciting of Jupiter's large moons, but it might be the smartest place to actually build something. And because it's farther out, travel between Callisto and the inner moons is easier than going from Mars to anywhere. Callisto could be a staging ground, a place where ships refuel, where supplies are stored, where people live while they work on the more dangerous moons closer to Jupiter. NASA has actually studied this. In the early 2000s, they looked at a mission concept called the Callisto Colony for exactly this reason. The radiation is manageable, the resources are there, and it's stable enough to build on. Okay, so if Jupiter's moons are so much better, why is everyone still obsessed with Mars? The answer is complicated, but it basically comes down to three things: distance, psychology, and money. Mars is closer. A trip to Mars takes about 6 to 9 months, depending on where the planets are in their orbits. A trip to Jupiter takes at least 2 years, and that's with current propulsion technology. It's a long journey, and long journeys means more fuel, more supplies, more risk, and more cost. But here's the thing, we're not ready to colonize Mars either, not even close. We don't have the life support systems, we don't have the habitats, we don't have the radiation shielding, we don't have reliable ways to produce food or water or oxygen on another planet yet. So the idea that we're going to Mars soon is kind of a fantasy anyway. We're decades away from any real colonization attempt. If we're going to spend those decades developing the technology we need, why not develop it for a place that actually has long-term potential? The second reason is psychological. Mars looks like a place humans could live. It has a sky, it has dirt, it has sunsets. You can look at pictures of Mars and imagine yourself there. Jupiter's moons look alien. They're icy, they're dark, they don't feel like home. But survival doesn't care about feelings. If the goal is actually keep humans alive long-term, we need to go where the resources are, not where the view is nice. And the third reason is money. We've already invested so much into Mars missions, rovers, orbiters, sample return plans. There's institutional momentum. Changing course means admitting that maybe we've been going in the wrong direction, and institutions don't like admitting that. But the science is clear. Mars is a dead end. Jupiter's moons are not. Let's get practical for a second. What would it actually be like to live on one of Jupiter's moons? First, you're living underground or underwater. There's no getting around that. The surface of these moons is not survivable for long periods. But underground doesn't mean cramped and dark. Look at how humans have built underground cities on Earth, subways, bunkers, research stations in Antarctica. We know how to make underground spaces livable. On Europa, you'd probably live in a submerged habitat. Think of it like an underwater research station. but permanent. The ocean around you is your radiation shield, your water source, possibly even your energy source if we can tap into hydrothermal vents. The technology to do this exists. We've built deep-sea submersibles that can handle extreme pressure. We've built habitats for aquanauts to live underwater for weeks at a time. Scaling that up is hard, but it's not impossible. On Ganymede or Callisto, you'd probably live in ice caves or excavated tunnels. Ice is an amazing building material in space. It's strong when it's cold, it blocks radiation, and it's everywhere. You could carve out entire cities inside glaciers with artificial lighting, hydroponics farms, and recycled air systems. The biggest difference from Mars is energy. On Mars, you'd rely on solar panels, but Jupiter is far from the sun, so solar energy is weak out there. Instead, you'd use nuclear reactors, small modular reactors that have been in development for decades. They're safe, they're reliable, and they don't need sunlight. Food would come from hydroponics or lab-grown protein. Same as Mars, really. Any space colony is going to need a closed-loop life support where you recycle everything. The difference is that on Jupiter's moons, you have abundant water to work with. Water is life support. It's drinking water, it's oxygen, it's hydrogen fuel, it's radiation shielding. Mars has some water ice, but not nearly as much. Here's the part that really makes me think we've been focused on the wrong target. Mars is a stepping stone to nowhere. If you colonize Mars, you're still stuck on a dead planet with no long-term potential. There's no path from living in underground bunkers on Mars to thriving civilization. But if you colonize Jupiter's moons, you're setting up infrastructure in a system that has everything you'd need for long-term expansion: water, energy, raw materials. And you're positioned near the outer solar system, which opens up the asteroid belt, Saturn's moons, and eventually interstellar missions. Think of it like this: Mars is a dead-end road. Jupiter is a highway interchange. And there's something else. If we ever want to build generation ships, massive ships that can travel to other star systems with whole populations living on board, we'd need to practice that technology somewhere. A colony on Europa's ocean or Ganymede's ice is basically a generation ship that doesn't move. It's the perfect testing ground. Imagine two futures. In one, we've spent 50 years building habitats on Mars. We've got a small population living underground, growing food in greenhouses, constantly fighting against radiation exposure and dust storms. It's survival, but it's fragile, and it's stuck. There's no next step, no expansion, just the same challenges forever. In the other future, we've built a colony in Europa's ocean, or Ganymede's ice, and it's thriving. Not because it's easy, it's not, but because the resources are there. Unlimited water, energy from tidal heating or nuclear reactors, protection from radiation, and from that base, we've started exploring the rest of Jupiter's moons. We've built ships that can travel between them. We've established a network of colonies, each specializing in different resources or research. Which future gives humanity a better chance? The one where we followed the science instead of the pretty pictures. Mars looks familiar, but survival doesn't care about comfort. It cares about resources, protection, energy, stability. And Jupiter's moons have all of that. Mars doesn't. We've been planning to colonize the wrong world because we've been thinking like tourists instead of survivors. We wanted a place that reminded us of home, but we needed a place that could actually keep us alive.